Okay, today we're going to be looking at more to do with straight lines and midpoints. Fairly straightforward. I've got some examples here to look at, and then we'll look at how we deal with midpoints. It's more of a sort of, we're going to use it later on in the course or other things. So let's have a think about the easy way to see where lines meet both axes. Well, they meet the axes. If you think about it, it was said before that the y-axis, because it's a vertical line, every vertical line is x equals a number, is x is naught. So all I do is stick x is naught into that, and I'm left with y equals 6. So 0, 6, so it crosses 1. And similarly, I would then solve, because the x-axis, its own equation is y is naught, so I'd solve 2x plus 6 equals 0, 2x is minus 6, x is minus 3, and y is 0. So that's the points where it would meet. And what I can do now, I can plot 0, 6, I can plot minus 3, 0, and I can draw the line. Similarly, when it's in this form here, I can quite easily stick either 1, 0, so x is 0, minus 5, y is 10, y is minus 2, and y is 0, means 4x is 10, x is 10 over 4, 5 over 2, 2.5. And I can plot 0 minus 2, I can plot 5 over 2, 0, and join them up. And I'm going to do that with this sort of thing here. Y equals 7x plus 81. Nice and straightforward. X is 0, y is 81. There it is, 81. Y is 0, 7x equals minus 81. X is whatever minus 81 over 7 is. It's there. So I'm going to write minus 81 over 7 for that. And I'm going to write 81 for there. And there's my sketch of the line. Okay, I've got enough information on there for my sketch. I can do the same for this one here in the same way. Stick x is 0, 3y is 6, y is equal to 2. So it crosses at 0, 2. Stick y is 0, minus 2x is 6, x is minus 3. So it's going to cross there, and look very similar to the one above, but with different numbers, and that's that. I might be given, it says, ask for the equation through that point, but parallel to this. What I have to do in this case here is rewrite it as y equals minus x over 4, and then plus 14 over 4. I can cancel down if I need that. Not required for this question. So I can read off m, the gradient I'm after, is minus a quarter. So I can state that any line parallel must be minus x over 4 plus c. Stick in the minus 2, 5. 5 is minus 2, 2 over 4, which is a half, plus c. c is 5 minus a half, 9 over 2. And then I can say y equals minus x over 4 plus 9 over 2. I'll times everything by 4 to get 4y equals minus x, or plus x, move across, and times that by 4 gives me 18. Because what I could have done, because I know it's parallel, I know that any equation parallel to that, any line parallel to that, must be 4y plus x equals a number. And I could have just stuck the minus 2 and 5 into that to get 20 minus 2 equals 18. So I could have gone from that version there to that version there, just by sticking those things into that. Remember this 14 and 18, they're not the points where the lines cross the y-axis. We can rearrange it if I need the c, but at the moment it's just 4y plus x is a constant for any parallel line. So that's worth bearing in mind for future reference. A couple more to do with our lines. We've got 3 points P, Q and R. It wants the line through P parallel to QR. First thing I'm doing, plotting the points, sketching them. Let's have a look what we've got then. So P, minus 2, 7. There's P. Q is the point 0, minus 6. So it's just 6 down. There's Q. And R is the point 4, 0. I can say that then I've got 6 down there, and I've gone 4 along there. Notice, because I've plotted it, even though I said 6 down, the gradient is going to be 6 over 4, which is 3 over 2. So I'm after this line here. So I can take m equals 6 over 4, 3 over 2. I can write y equals 3x over 2 plus c, and I can use the point P. So y equals 7, and then minus 6 over 2 is minus 3 plus c equals 7 plus 3 is 10. And say that y equals 3x over 2 plus 10. And that is parallel to this line, QR, and goes through the point P, and that's the equation that I'm after. Last one for this bit is got this alternative way to rewrite the equation of a line. Well, we've seen it before. It's y minus y1 equals m bracket x minus x1, because m is the change in y over change in x. And it's just a rearranged version of that. It has its uses, particularly for this sort of one here, with fractional gradients, as we'll see later on. So all I do, I use that's x1, that's y1, and that's m equals 5, and stick it in. So y minus 6 plus 6 equals 5 bracket x minus 2, which is 5x minus 10, and then move the plus 6 across to become minus 6 to get y equals 5x minus 16. When I do it here, y minus 8 equals 4 over 9, x minus 5. Why this method is good is because what I can do with it from this form is I can cross multiply, basically times everything by 9, which gets rid of the 9 from this side and puts it over here. So it's equivalent to, I wouldn't write this out in future, but what I get is that. And then I times it all out and tidy it all up. So I'd get 9y minus 72 is 4x minus 20, or 9y equals 4x, and 72 minus 20 is plus 52. And that's a tidy version without fractions in my equation. If I need the gradient, I've got to divide by 9 again, 4 9. So if I need the intercept, 52 over 9, which I don't think cancel down, I've got to write it in that form there. But if I want just an equation in the line, that will do the job. And last little bit from this part here, midpoints. Nice and straightforward. Your midpoints is the average of the coordinates. What I mean is the average of the x-coordinates is the x-coordinate of the midpoint, then the average of the y's. So what I would do in this case, I'd be doing 1 plus 4 over 2 and 15 plus 7 over 2. So 5 over 2, 2.5, 22 over 2, 11. Same deal for this one. I'd be doing minus 9 minus 1 over 2 for the x's, and 17 plus 32 over 2 for the y's, which is minus 10 over 2, minus 5 there, and 49 over 2. Some people do it by sketching. We will use it where we're looking at sketches or whatever's, but then they will find the change in y, change in x, halve them and add it onto one, take it off another. It's long-winded. It's the average of the coordinates, average amount. Where we're going to be seeing this is later on when we're looking at perpendicular bisectors between 2 points, where we're looking at equations of circles, where we know we've got the ends of a diameter, so the centre of the circle is halfway in between. That's where we're going to go with it later on. But that'll do for now.